Okay, in this problem, we have a voltage that's across a set of resistors that are connected in parallel. So you have to remember for resistors connected in parallel, right, we have to get the total resistance. There are a couple of things we need here. We need Ohm's law, V equals IR, but that's going to have to be the total resistance to get the total current, right? And we've got to figure out what is the total resistance. So we're going to have to do 1 over R1 plus 1 over R2 plus 1 over R3 plus 1 over R4, right? And then invert that to get the total resistance. And so V equals IR, R is this, we've got our 4 resistances, and so we've got to put all of that together. And I'm just going to pop over to Excel, 162, 268, 358, 332. Now I have to invert these, right, 1 over that, so I'm just going to make my life easy by using Excel and copying and pasting that formula in. Okay, and I need to sum all of those and then take the inverse. So we get the total resistance is 63.66 ohms. Now we have the resistance, and we need to solve for the current, which we've done in an earlier problem. So the current is the voltage divided by the resistance. So now we have our voltage 162 volts divided by 63.66 ohms. Go back to Excel again. 162 volts. 162 volts divided by the resistance is 2.54 or 2.54 amps. Now there's another way to go at this. Since when resistors are in parallel, the same voltage is across every one of them. We could add up. I1 is V over R1, right? So 162 volts over 162 ohms. Well, that's going to be 1 amp. We got lucky on that one. I2 is V over R2, which is going to be 268 volts. Oh, sorry, 162 volts over 268 ohms. That's going to give us amps. Okay, so let's go to Excel. And I'm going to just go through and do all of them really quick over in Excel. So I1 is going to be the voltage divided by the resistance 1. I2 is going to be the voltage divided by resistance 2. The voltage divided by resistance 2. I3 is going to be the voltage. I can avoid hitting my mouse wheel. And then I4 is going to be the voltage divided by R4. And so the total current then is just the sum of all the currents, which gets exactly to where we were before, right? So 0.604, and we got I3, it's 162 over 358, and that's amps again, amps there, 162 over 358, that came to 0.453, and then I4 is 162 volts over 332 ohms, and and that came to 0.488. And then we sum all of those up and we get right back to where we were before, 2.54 amps. And that's it for this problem.